Hi everyone, this is Ivanos, your tutor for today's topic, the false position method. False position method, also called the method of false position, regular falsi, and linear interpolation method, is an alternative to bisection method when it comes to graphical insight. Unlike the bisection method where the interval is cut into half and find the real root in between that intervals, in false position method, the interval is now cut in unevenly to where the real root lies, with no account to the magnitude of the f x sub 1 and f x sub u. It follows the formula x sub r equals to x sub u minus function of x sub u times x sub l minus x sub u over function of x sub l minus f of x sub u. To know better, let's make an example. Determine the real root of the following function. F of x equals to 4x cubed plus 6x squared plus 7x equals to 2.3 minus 2.3. The initial equation will be x sub l equals to 0, x sub u equals to 1. The function of the x sub l will be negative 2.5 and the function of the x sub u is equals to 2.7. Then we can substitute these variables to the formula. X sub r equals to x sub u minus fx sub u, x sub l minus x sub u over f x sub l minus function of x sub u. 1 minus 2.7 0 minus 1 over negative 2.5 minus 2.7. The answer will be 0.4808. This means that it can be the real root may be between 0 and 0.4808 or 0.4808 and 1. To determine if the real root is at the interval 0 and 0.4808, we must multiply its functions. The answer becomes negative 0.3808, which means that the real root lies between 0 and 0.4808. For the second iteration, x sub l is 0, giving 0, and x sub u becomes 0.4808. Then, same steps, x sub r equals to 0.4808 minus 0.1232 as the function of x sub u times max 0 minus 0.4808 over negative 2.5 as 0.1232. The answer will be 0.4582. This means that the real root may be between 0 and 0.4582. For the third iteration, x sub u 0, x sub u is 0.4582, f of x equals to 2.5, and fx sub u equals to 0.0325. Same steps. The answer will be 0.4520. On the table, when we plot the iterations 1, first, second, third, x sub L, x sub U, and x sub R, the x sub R becomes the new x sub U in the second and third iteration. Now, we must get the absolute approximate relative error. Its formula is absolute value of new value minus old value over new value times 100. In the second iteration, the approximate relative error is 4.9%. In the third iteration, the approximate relative error equals 1.37%. When we subtract this number over the new value, the percentage arises. In solving the true error equals to true value minus approximate, and the answer for that will be over the true value times 100. The true value is 0.4501 as stated when we solve it to the calculator. In the first x sub r, the true error percentage equals 6.3%. In the second iteration, it becomes 1.77%. In third iteration, 0.42%. Which means that as we go more iterations, we becomes nearer to the true value that of the real root.